everybody. I hope you had a great week and did excellent on exam 2. Today we're going to go over some chapter 9 example problems. The first question asks for the standard error, knowing what n and the sum of squares is. We can't find the standard error until we first determine what the sample variance is. Sample variance is the sum of squares over n minus 1, and that will give us a sample variance of 16. Now we can find the standard error, which is the square root of the sample variance divided by n. So we'll have the square root of 16 divided by 4, which is the square root of 4, and that equals 2. The next question gives us the specific values for a sample, and we have to compute the sample mean, standard deviation, and the standard error for m. I like to start by placing my scores in a vertical line so that I can do my calculations in a way that I can understand. In order to find the mean, we're going to add up all of our scores and divide by the number of scores that we have. So in this case, it'll be 8 plus 2 plus 7 plus 4 plus 7 plus 8 divided by 1, 2, 3, 4, 5, 6. And our mean is 6. Now we'll take each score and minus our mean, which is 6. And that's going to tell us how much of a deviation each score is from the mean. Then we're going to square each of these numbers and add them up. That will give us the sum of squared deviations, which is SS. Now that we have the sum of squared deviations, we can plug that into our sample variance equation and divide by the degrees of freedom, which is n minus 1, and we come up with a sample variance of 30 divided by 5, which is 6. So S, which is our sample standard deviation, is the square root of 6, which equals 2.45. Now that we have our sample variance, we can solve for our estimated standard error, which is the square root of the sample variance divided by n. In this case, it'll be the square root of 1, which equals 1. The next question asks for the estimated standard error, the t-value, and the critical value for t, given the sum of squared deviations, a sample mean, and a number in the sample. We use the sample variance equation to determine the standard error, and from that, we'll get a value of 3. Then we can plug our standard error into our t equation, and we'll take our sample mean minus our population mean if there's no effect, and divide it by the standard error. We'll receive a value of 3.5. In order to determine whether this is significant or not, we'll have to take a look at the critical t-value. And to determine what the critical t is, first we have to figure out the degrees of freedom, which is n minus 1. So you'll adjust your degrees of freedom and then move the sliders back and forth until you have 2.5% on one tail and 2.5% on the other tail, since we're running a two-tail test with an alpha of 5%. We'll take a look at our t-value, which is 3.5, and decide whether it is beyond the critical value of 2.447. And since it is, we will go ahead and reject the null because it's beyond our critical t-value. To measure the effect size for a hypothesis test using a t-statistic, we'll calculate Cohen's d by taking the sample treatment mean and subtracting the mean for the untreated population. Then we'll divide the difference by the sample standard deviation. In this example, we come up with a value of 1.3, which is a large treatment effect. Next, we are asked to calculate the confidence interval, which is another way to describe the size of a treatment effect. In this example, we are asked to calculate a 95% confidence interval, which is the interval of values that is likely to contain the unknown population mean. So we will take the sample mean and add and then subtract our t-value multiplied by the estimated standard error. So 40.5 is our sample mean, 2.447 is the lower end of our confidence interval, and 3 is our estimated standard error. We'll first subtract them from the mean to determine our lower bounds of our confidence interval. Then we'll add them to the mean to determine the upper bounds of our confidence interval. So we can be 95% certain that our unknown population mean is going to be between these values. Our next problem asks us to calculate the estimated standard error, the t-value, determine the critical regions, and calculate r squared. So first, with the estimated standard error, we have the square root of our sample variance divided by n, and we come up with a value of 1.5. Next, we'll calculate our t-value by taking our sample mean, subtracting the population mean, and dividing the difference by our estimated standard error, which is 6 divided by 1.5, and that equals 4. Next, we have to come up with our critical t-values, and in order to come up with the correct values, we have to know what the degrees of freedom are, which is our n minus 1. In this case, it is 35 degrees of freedom. And we'll choose a one tail with an alpha level of 0.01, which means that 99% of the values will be in the body and 1% will be in the extreme tail. When we move our slider over, this gives us a critical value of 2.438. In this question, we are asked to provide the percentage of variance accounted for by the treatment, which is r squared. The formula is r squared equals t squared divided by t squared plus degrees of freedom. So we have 16 divided by 51, which gives us an r squared value of 0.314. This is interpreted as having a large effect. I hope these examples were helpful for you in taking your Chapter 9 end of chapter questions, and I hope to see you next session. Take care.